In second PU maths paper, last part is part E, and that is important for 10 marks, and it is divided into 6 marks plus 4 marks. Hello second PU students, as I said in the previous video, now we are going to discuss about part E, that is very important for 4 marks. So let us discuss 4 marks important questions. Finding the k value question from continuity and differentiability chapter, that is question number 47. Find the values of k so that the function is continuous at the indicated point. This is the question. So there are 4 different questions. First one is f of x is equal to kx square if x is less than or equal to 2. 3 if x is greater than 2 at x is equal to 2. First you have to write the given function is continuous at x is equal to 2. So in the question itself they have given that the given function is continuous. So you have to write that the given function is continuous at x is equal to 2. Next step, it is very important step. If the function is continuous at any point, the condition is LHL is equal to RHL is equal to f of 2. Left hand limit is equal to right hand limit is equal to f of 2. So left hand limit you have to take less than sign function. For RHL you have to take the function in which you have greater than sign. Of f of 2 you have to take the function where you have equal sign. LHL limit extends to 2 power minus f of x is equal to, for RHL limit extends to 2 plus f of x is equal to f of 2. Limit extends to 2 minus kx square. So for LHL we have to consider the function which has less than sign, that is kx square. Kx square is equal to, for RHL we have to consider the function which has greater than sign, that is, what is the function here? 3, which is equal to k 2 square, because at x is equal to 2 we have the function kx square. So in the place of x we have 2 here, so substitute x is equal to 2, we'll get k2 square. Next step, apply the limit. Wherever x is there you have to apply the limit. What is the limit here? 2. So k2 square is equal to 3 is equal to k2 square. So at this step, see, this and this both are same. So you have to consider any one to find the k value. So 3 is equal to 4k, k is equal to 3 by 4. Similarly, we can solve next question. F of x is equal to kx plus 1 if x is less than or equal to 1, 3x minus y if x is greater than 5 at x is equal to 5. Here also the given function is continuous at which point? At x is equal to 5. Condition LHL is equal to RHL is equal to f of 5. LHL limit extends to 5 power minus f of x is equal to limit extends to 5 plus f of x is equal to f of 5. Limit extends to 5 minus, for LHL what is the function? Kx plus 1. For RHL what is the function? 3x minus 5 greater than sign function, which is equal to f of 5 equal. So equally here we have, so function is kx plus 1. What is x here? 5. K of 5 plus 1. Next apply the limit. K of 5 plus 1 is equal to 3 of 5 minus 5 is equal to k5 plus 1. So here in the place of x we have applied the limit. Consider any one. So 3 5s are 15 minus 5 is equal to 5k plus 1. 15 minus 5 10, 5k plus 1, shift 1 to LHS because we have to find the value of k. 10 minus 1 9, that is equal to 5k. So k is equal to 9 by 5. So this is about these two questions. Next we'll discuss about third question is f of x is equal to kx plus 1 if x less than or equal to pi cos x if x greater than pi at x is equal to pi. So here the given point is pi. First step, the given function is continuous at x is equal to pi. Next condition, LHL is equal to RHL is equal to f of pi. Limit x tends to given point is pi. So pi minus f of x is equal to limit x tends to pi plus f of x is equal to f of pi. So here you have to write the given point. Next, limit x tends to pi minus, what is the function for LHL? Less than sign function kx plus 1 is equal to limit x tends to pi plus for RHL, what is the function? Cos x, which is equal to k pi plus 1. So apply the limit k pi plus 1 is equal to cos pi is equal to k pi plus 1. Consider any one. So cos pi value is minus 1, that is equal to cos pi is 180 degree. So cos 180 degree is minus 1 is equal to k pi plus 1. Shift plus 1 to LHS. So minus 1 which is equal to k pi. Minus 2 is equal to k pi. K is equal to minus 2 by pi. So next question is little bit different compared to previous three questions. So f of x is equal to k cos x pi minus 2x, comma, if x is not equal to pi by 2. 3 if x is equal to pi by 2 at x is equal to pi by 2. Here they haven't given less than or equal or greater than sign. Instead of that they have given equal and not equal sign. So for this kind of questions you have to take the conditions directly. Limit extends to pi by 2 f of x. So here we don't have LHL and RHL. So for both LHL and RHL we have to consider the same function. So that's why we are taking it directly. Limit x tends to pi by 2 f of x is equal to given point is f of pi by 2. Limit x tends to pi by 2. What is the given function here? K cos x pi minus 2x. At x is equal to pi by 2 function is 3. Next, limit x tends to pi by 2. So here if you apply the limit k cos pi by 2 pi minus 2 pi by 2. So cos pi by 2 value is 0. Pi minus 2 pi by 2 cancel 2 and 2, pi minus pi is equal to 0. So you'll get 0 by 0 here. That is indeterminate form. That's why you have to modify here. Limit x tends to pi by 2. K cos x can be written as sine of pi by 2 minus x, because pi by 2 minus, that is first quadrant. In the first quadrant sine is positive and this is vertical line angle. So sine will become cos. So again we'll get back the cos x. So cos x can be written as sine of pi by 2 minus x. Divided by, here you can take 2 common. If you take 2 common, pi by 2 minus x, which is equal to 3. K by 2 both are constant, so take it outside of the limit. And in the first PU you have studied this sandwich theorem. Limit x tends to 0, sin x by x value will be equal to 1. So limit, so in the place of x, what do we have here? Pi by 2 minus x. Denominator is also pi by 2 minus x. So here just rearrange this. So limit pi by 2 minus x tends to 0. Sine of pi by 2 minus x by pi by 2 minus x is equal to 3. This is in the form of limit sin x tends to 0, sin x by x. So this value will be equal to 1. So we have k by 2 into 1 is equal to 3. So k is equal to 6. I hope you understood this concept. So in the next class, the next video, we'll discuss about 4-mark determinant questions. Thank you so much for watching this video. Share this with your friends and don't forget to subscribe.